fractions. So when an equation has fractions, we're going to clear the fractions by multiplying each term by the least common denominator. And then after multiplying, we can reduce to remove the fractions. So let's look at the example 1. So we're going to solve for x below. So we have 1/8 x minus 2 over 4 is equal to 1/2. Well, if we need to get rid of all the fractions, we're going to multiply by the least common denominator. Let's go ahead and look at multiples to find the least common denominator. So we have 2, 4, 6, 8, 10. Let's just go up to there. 4, right, is 4, 8, 12. And then 8, right, would be 8, 16, 24. So let's see. Well, 8, and 8. So 8 would be our least common denominator. It's the first number between all these numbers that would have a common denominator. So what that means is we're going to go ahead and multiply each term by 8. So if we multiply every term by 8, it actually does not change the equation at all, right? We're not changing it, we're just making it easier for us to solve. So this means that our equal sign stays the same. So remember when we talked about like the scale, when we measure things, like so if we added on one side, right, then we have to add to the other. Well, if we add, right, if we go ahead and multiply on one side, we have to multiply every term. So let's go ahead and now multiply this out. So, well, 8 over 8, right, this just becomes 1, so we can just reduce that. Then this is 8 over 4. Well, we can, right, divide both by 4. So that's 4 divided by 4, so that's 1. 8 divided by 4 is 2. Then we can divide by 2 here. So 2 divided by 2 is 1. 8 divided by 2 is 4. Right, and we can also, if we look at this, look at it. So 1, 2, 3, 4. So notice that I took 4, right? On the fourth multiple, it was equal to 8. So just kind of to start kind of seeing some common things going on here, right? Where 4 was the second one, 8 was the first one. So see how like there's a lot of patterns in math, and that's kind of the fun part about discovering them. So now we have 1, right? 1 times 1. Here we have 2 times 2. This one's here's 1 times 4. So let's go ahead and now multiply out. So 1 times 1 is just 1, and that's just x then. Then 2 times 2 is 4, so we have minus 4. And then we have 1 times 4, and so that's 4. Now we need to go get x by itself. So all we need to do is add 4 to both sides. Right, guys? Then we have 1x. This is just zeros. We don't even need to write it. 4 plus 4 is 8. So what is x? X is equal to 8, right? 1x is equal to 8. It doesn't change, right? If this is 1x, this is x, right? 1x and x these are the same. So that, right, this would also be your answer right here. So now let's look at the next example. Example 2. So the temperature in a town is 58 degrees and rising 5-6 every hour, right? So it's not even a whole degree yet. So then another town far away, the temperature is 64 degrees and falling 2/3 of a degree every hour. So in how many hours will the temperatures be equal? So we're going to go ahead and solve for x in below, which would be the hour. But these are the same temperature in both towns. So let's go ahead and rewrite this. We have 58 plus 5/6x, which is equal to 64 minus 2/3 x. So notice we have two fractions. So let's go ahead and find the least common multiple between them. So we have 3 and 6. So we have 3, 6, 9, 12. Let's look at 6. We have 6, 12, 18. Now what's our least common multiple between them? What would be the 6, right? We do also have 12, and we could do 12, but it would make all the numbers bigger. And so just to reduce even further, we'll just do the least common multiple, or which will become our least common denominator between the two, which would be 6. So what we're going to do is multiply then each term by 6. This will get rid of it on the fraction side, right? We get rid of our fractions, and then we keep everything the same. So we multiply every term by 6. It does not change at all our numbers in terms of them being equal to one another, right? We didn't really change anything. We just made it easier. So let's get our calculators out, because 6 times 58. Let's go ahead and do that there. $348. Well, 5 6 times 6. Well, this 6 over 6 is just 1. So then we're left with 5 times 1. So that's just 5x. Then we have 64 times 6. 384. Then we have this 2/3 times this 6. Well, 3 divided by 3 is 1. 6 divided by 3 is 2. Then we're left with going 2, right? This 2 times this 2. So that's minus 4. And then we just have our x. Now we need to get the x by itself. And so the first step we're going to be doing is we're going to go ahead and just add 4x to both sides. So we're starting to get it by itself. So we're getting rid of it on the right hand side, which then leaves us to 348. 5x plus 4x is 9x. Then we're left with 384. So if we want to get 9x by itself, right, to eventually get x by itself, we are going to go ahead and subtract 348 on both sides. So I hope you're starting to see a pattern throughout this whole last unit, right? We've been building on everything here. So we are now going to go ahead. This becomes 0. Then we're left with just 9x. Then we have 384 minus 348, which becomes 36. And then our final step, we'll get x by itself by dividing by 9. So this just becomes 1, so that just becomes x. Then 36 divided by 9 becomes 4. So x becomes 4. So we saw that in 4 hours, these two temperatures will be equal. And we can go ahead and plug that in to make sure that these are indeed equal, and we can figure out what that temperature would be in 4 hours.